We have always called the Earth our home, our mother, the single blue and white cradle of all known life in a silent and seemingly empty cosmos. But what if this is only a story we tell ourselves? A story born of an incomplete memory? What if our true genesis, the original Eden of our biology, lies not beneath our feet but above our heads, in the faint red light of the fourth planet from the Sun? This is the story of a radical, deeply unsettling and scientifically plausible idea, the Mars origin hypothesis. From the clear skies over the southern hemisphere, Mars appears as a steady reddish star, a familiar and constant point of light in the great celestial river of the night. For all of history, we have seen it as another world, a neighboring planet in our solar family. But this theory asks us to look at that red light again, and to see not another world, but perhaps our first. It asks us to consider the possibility that we are all, in the most profound and literal sense, Martians. To begin this journey, we must first understand the Mars of today, the world that our rovers and orbiters have so beautifully and painstakingly revealed to us. It is, by every measure, a dead world. Its atmosphere is a thin, ghostly shell, less than 1% the density of our own, composed almost entirely of carbon dioxide. It is too thin to breathe, too thin to hold in heat, and too thin to protect from the harsh realities of space. The surface is a place of brutal extremes. In the faint sunlight of a Martian summer day, the temperature might rise to a comfortable 70 degrees Fahrenheit, but when the sun sets, the heat bleeds away into the thin air, and the temperature plummets to 100 degrees below zero. It is a world locked in a permanent deep freeze, with no thick atmosphere and no global magnetic field to protect it. The surface is constantly bombarded by the unfiltered, sterilizing radiation of the sun and the cosmos beyond. The landscape is one of breathtaking but desolate beauty. It is a global, rust-colored desert, a world of silent red rock and fine pervasive dust. Great dormant volcanoes, the largest in the entire solar system, stand as silent monuments to a more violent and energetic past. A vast canyon system, the Valles Marineris, dwarfs our own Grand Canyon, a great gaping wound in the planet's crust, and the winds, unimpeded by vegetation or oceans, can whip the red dust into global dust storms that can shroud the entire planet for weeks at a time. This is the Mars we know, a ruin, a ghost of a planet, a silent, frozen, irradiated museum of a world that once was. But this is not the Mars that always was. Buried in the geology of that dead world is the undeniable evidence of a different past. A past that is almost too fantastic to believe. Our probes and rovers have acted as robotic geologists, uncovering a story, written in the stone, of a Mars that was once a paradise. A Mars that was for a time more like Earth than the Earth we know today. The evidence begins with the atmosphere. Geological and mineralogical clues strongly suggest that billions of years ago, Mars had a thick, dense atmosphere, perhaps even denser than our own is today. An atmosphere thick enough to hold in the sun's warmth, to create a powerful greenhouse effect, and to maintain temperatures that were well above the freezing point of water. An atmosphere thick enough to create a blue sky, and an atmosphere that could support the most precious and life-giving substance in the cosmos, vast, stable, globe-spanning oceans of liquid water. Our orbiters have mapped the surface of Mars with incredible precision, and the data reveals the faint, ghostly outlines of ancient shorelines. In the northern hemisphere of Mars, there is a vast, smooth, low-lying basin, the Vastas Borealis. The edges of this basin are marked by features that look for all the world like the coastlines of an ancient ocean that once filled this entire region, an ocean that may have held more water than our own Arctic Ocean. And from the highlands to these lowlands, we see the undeniable evidence of the rivers that once flowed into this great sea. Our rovers have landed in the beds of ancient, dried-up lakes and explored the deltas of long-vanished rivers. At Jezero Crater, the landing site of the Perseverance rover, we see a perfectly preserved river delta. It is a beautiful fan-shaped deposit of sediment, a feature that can only be formed when a flowing river empties into a large placid body of water, like a lake. We can see the layers of sediment. We can see the winding channels of the river that fed it. It is the fossilized ghost of a living waterway. In Gale Crater, the Curiosity rover has spent years drilling into layered sedimentary rock. These are not volcanic rocks. They are mudstones formed layer by layer at the bottom of a lake that existed in the crater for tens of millions of years. This was not a fleeting, temporary pond. It was a stable, long-lived body of water, an environment that could have been a perfect cradle for life. Across the entire planet, we see the dendritic, branching patterns of ancient river valleys, the snake-like meanders of channels that once carried flowing water across the landscape. We see great, catastrophic outflow channels, carved in a matter of weeks by mega-floods of unimaginable scale, perhaps from the sudden melting of vast subsurface ice deposits. The evidence is overwhelming, and it all points to the same stunning conclusion. The minerals on the surface tell the same story. Our rovers have found vast deposits of clay minerals known as phyllous silicates. Clays are a profound clue because they can only form through the long-term interaction of rock with stable, neutral, liquid water. They are not formed in flash floods or by acidic water. They are the signature of a calm, wet, and habitable environment. In other regions, we find deposits of sulfates. These minerals tend to form when water is more acidic, suggesting they are from a later period in Martian history, a time when the planet was beginning to change, to dry out, and the chemistry of its water was becoming harsher. We have even found small, spherical concretions of the mineral hematite, nicknamed blueberries by the rover teams. These too are a type of mineral that on Earth forms almost exclusively in the presence of standing water. Every piece of evidence, from the grand scale of the Northern Ocean basin to the microscopic chemistry of the clay minerals, all sings the same harmonious song. Billions of years ago, Mars was a blue world. It was a world of rivers, lakes, and perhaps even a great globe-spanning ocean. It had a thick protective atmosphere, a blue sky, and white clouds. It had all of the necessary ingredients for life as we know it. It was for a time a true sibling to our own Earth, a second Genesis world in our own solar system. This lost paradise was not a theory, it was a reality. And this reality leads to the next, a most profound question, a question that will set the stage for our entire journey. If Mars was once so much like Earth, a true and habitable world, what happened to it? How does a paradise die? The midday sun over the pampas warms a world that is vibrantly, undeniably alive. The air is thick with oxygen, the ground is green with vegetation, and the water flows in rivers and oceans. It is our perfect and familiar template for a living world. The evidence we have gathered now forces us to apply that same template, that same vibrant potential, to the red dot in our sky. It compels us to imagine a time, long ago, when that desolate world was not a ruin, but a thriving, dynamic, and breathtakingly beautiful place. This ancient, wet, and habitable era of Martian history has a name. Geologists call it the Noachian period, named after the biblical story of the Great Flood. It was an epoch, lasting for hundreds of millions of years, from roughly 4.1 to 3.7 billion years ago, when water was the dominant force shaping the planet's surface. This was not a brief, fleeting moment of warmth. It was a long and stable age, a vast window of opportunity for the miracle of life to potentially take hold. Let us try to imagine what it would have been like to stand on the surface of Mars during this ancient time. The air would have been thick enough to breathe, though its composition would have been different, likely rich in carbon dioxide and nitrogen. The sky would not have been the faint pinkish tan we see today, but a deeper, perhaps butterscotch or even pale salmon color, a hue dictated by the unique chemistry of its atmosphere and the way it scattered the light of a distant sun. The sun itself would have appeared smaller and fainter in that sky than it does from Earth, casting a cooler, gentler light upon the landscape, but the thick atmosphere would have trapped that gentle heat, creating a powerful greenhouse effect that kept the world temperate and warm. Great white clouds of water vapor would have drifted through the Martian sky, a sight that has been absent for billions of years. And the landscape would have been one of water. Imagine standing on the shores of the great northern ocean, the Vastitas Borealis, hearing the sound of waves, real waves of liquid water, lapping against the dark volcanic rock of the ancient highlands. Imagine seeing the morning frost glistening on the immense slopes of the great volcano, Olympus Mons, which would have been the largest island on the entire planet. Imagine the sound of rain, of a real and persistent Martian rain, falling upon the surface, feeding the rivers that carved the great channels we now see as dry, dusty fossils. This ancient Mars was a world of profound contrast, a planet of two distinct hemispheres. This is a feature known as the Martian dichotomy. The southern hemisphere is a land of ancient, heavily cratered highlands, some of the oldest terrain in the entire solar system. The northern hemisphere, by contrast, is a vast, smooth, and much younger lowland basin. It is this great basin that the Northern Ocean would have filled, creating a world that was, in effect, a water hemisphere and a land hemisphere, a planet of one great supercontinent and one great globe-spanning sea. And this world had a climate. It had a functioning dynamic water cycle, just like the Earth. The evidence is carved into the very stone. We see the erosion patterns of rainfall on the rims of ancient craters. We see the vast river networks that could only have been formed by a persistent and stable source of precipitation. We can imagine a world with weather, with storms that raged over the Northern Ocean, with clouds that gathered around the great volcanic peaks, and perhaps even with snow and ice that accumulated on the polar highlands, melting in the spring to feed the great rivers. The existence of this warm, wet climate so long ago presents its own profound mystery, a puzzle known as the faint young sun paradox. 4 billion years ago, our sun was younger, smaller, and about 30% dimmer than it is today. Even with a thick carbon dioxide atmosphere, it is difficult for our climate models to explain how Mars could have stayed warm enough to maintain liquid water. This suggests that there is something missing in our understanding. Perhaps the atmosphere had other, more powerful greenhouse gases, or perhaps the answer lies not in the sky, but in the ground. A planet that is alive on the outside is often alive on the inside. The evidence suggests that during the Noachian period, Mars was a geologically active world. It had a hot, molten core, which would have generated a powerful protective magnetic field, just like Earth's. This magnetic shield would have protected the thick atmosphere from being stripped away by the solar wind, and this active interior would have powered a system of volcanoes and perhaps even plate tectonics. The great shield volcanoes of the Tharsis region, Olympus Mons and its 3 colossal neighbours, are a testament to this active past. Their immense size tells us that the Martian crust was likely a single stationary plate, allowing the volcanoes to grow to unimaginable size over a stable hotspot in the mantle for hundreds of millions of years. This constant volcanism, would have pumped enormous quantities of gases, including carbon dioxide and water vapor, into the atmosphere, helping to maintain the powerful greenhouse effect that was needed to keep the planet warm. So, the picture becomes clearer. We are not just imagining a world with water, we are imagining a complete functioning planetary system, a world with a thick atmosphere and a bluish sky, a world with a vast ocean and flowing rivers, a world with clouds and rain and snow, a world with a hot, active interior, great volcanoes, and a protective magnetic shield. It was a world that had every single ingredient that we believe is necessary for the emergence of life. It was, for a long and stable period of cosmic time, a perfect cradle. This lost paradise was not a fleeting possibility. It was a robust and long-lived reality. The evidence is no longer in dispute. The only remaining question from this ancient golden age of Mars is not if it was habitable, but if it was in fact inhabited. On a quiet Sunday, a day often set aside for contemplating the great questions of origin and meaning, the story of ancient Mars presents us with the most profound what-if in our solar system's history. The undeniable evidence of its warm and wet past, of this lost blue world, is not just a geological curiosity. It is a discovery that forces us to re-evaluate our own origins, to question the very bedrock of our identity as a species. The question we are left with, as we gaze upon the fossilized rivers and the dry ocean beds, is not just whether this world could have supported life, but whether it was in fact the first and best location for life to begin. To answer that question, we must travel back in time, back to the chaotic dawn of our solar system, some 4 billion years ago, and we must compare the conditions on the two sibling worlds, the young Earth and the young Mars. And what we find when we do so is a stunning reversal of fortunes. The planet that is now a paradise was once a hell, and the planet that is now a hell was once a paradise. The key to this reversal is a simple matter of size. Mars is a much smaller world than the Earth. It has only about half the diameter and about 1/10 the mass. In the violent early days of the solar system, when the planets were still glowing, molten balls of rock, this difference in size was everything. A smaller object cools down much faster than a larger one. While the young Earth remained a raging molten inferno for hundreds of millions of years, its surface a global ocean of magma under a thick, toxic atmosphere of steam. The smaller Mars cooled rapidly. It was on Mars that the first solid crust formed. It was on Mars that the first oceans were able to condense from the steamy atmosphere and fall as rain, pooling in the great ancient craters and the vast northern basin. While the Earth was still being pummeled by the final giant asteroids of the late heavy bombardment, a period of unimaginable violence that would have sterilized any nascent life, Mars was already entering its long, peaceful and habitable Noachian period. It had a head start, a profound hundreds of millions of years head start. During the very time that Earth was an impossible and hellish world, a place utterly inhospitable to life as we know it, Mars was a world of calm, quiet, liquid water oceans. It was a world of stability, a world where the delicate and complex chemical processes that are thought to lead to life could have unfolded, undisturbed. The window of opportunity for life to begin opened on Mars long before it opened on Earth. But water alone is not enough. Life requires a specific set of chemical ingredients. These are the 6 essential elements, known by the acronym CHNOPS: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These are the fundamental building blocks of every living thing we have ever seen. And our robotic emissaries, our rovers on the surface of Mars, have confirmed with absolute certainty that every single one of these elements was present in abundance in the ancient rocks and clays of habitable Noachian Mars. The Curiosity rover, in Gale Crater, drilled into the mudstone of the ancient lakebed and found a chemical environment so rich, so benign, that if you had transported a flask of Earth microbes back in time and poured it into that lake, they would have had everything they needed to survive and to thrive. It was not a toxic or exotic environment. It was a place of fresh, life-sustaining water, a place containing all the raw materials for biology. And life requires one more thing. It requires energy. The first life on Earth is thought to have harnessed chemical energy from the superheated, mineral-rich water gushing from hydrothermal vents deep on the ocean floor, a process called chemosynthesis. Given that ancient Mars had a hot, active interior and vast, deep oceans, it is almost certain that it too had these same life-giving hydrothermal vents. The energy was there, the spark plugs were present. We can now paint a complete picture of this ancient Martian cradle. It was a world littered with what Charles Darwin once famously described as warm little ponds. The countless craters left over from the early bombardment would have filled with rainwater, creating thousands of small, isolated lakes. These lakes would have been rich in the dissolved minerals from the surrounding rock. They would have been warmed by the geothermal heat from the planet's active core. They would have been exposed to the gentle, nourishing light of the faint young sun. They were, in every sense of the word, the perfect incubators for life to begin. So let us consider the argument from probability. We have two planets, side by side. Planet A, the young Mars, is calm, stable, cool, and has all the necessary ingredients for life in abundance for hundreds of millions of years. Planet B, the young Earth, is at the same time a violent, molten, chaotic hellscape. If the emergence of life is a natural process, a likely outcome when the right conditions are met, then where is life more likely to have started first? The answer is unavoidable. Life should have started on Mars. This is the core of the scientific argument. It is not a wild speculation. It is a sober and logical conclusion based on our best and most current understanding of planetary formation and the requirements for life. The most conservative, the most reasonable place in our solar system to look for the origin of life is not, in fact, our own Earth. It is Mars. This makes the search for ancient life on Mars not just a search for alien life, but a search for our own ultimate origins. It is a quest to find the first chapter of our own story. The evidence for this ancient habitable paradise is now so overwhelming that it has become the consensus view in the planetary science community. The Mars we see today, the cold, red, and dead world, is an imposter. The true original Mars was a blue world, a water world, a living world. The case is made. The argument is laid bare. Billions of years ago, Mars was not just habitable, it was the first and best habitable world in our solar system. The stage was set, the ingredients were all present, the energy was available, and the time was right. Life, it seems, should have begun there. Which leads us to the next inevitable and chilling chapter in our story. If such a paradise was born, how was it lost? And if life did indeed begin in those warm ancient waters, what became of it? The Sunday afternoon sun feels eternal, a constant and dependable source of the warmth and light that sustains our world. It is difficult to imagine our own blue sky ever fading, our oceans ever vanishing, but the story of Mars is a profound and chilling reminder that even a paradise is not permanent. It is a lesson written in the geology of an entire world, that a planet can be born, can live a vibrant and dynamic life, and then, through the inexorable and sometimes tragic unfolding of cosmic law, it can die. The very thing that gave Mars its head start in the race for life, its small size, was also its fatal flaw. A smaller planetary body, like a smaller cup of coffee, loses its internal heat to the cold of space much, much faster than a large one. While the great massive engine in the heart of our Earth has remained a churning molten furnace for 4.5 billion years, the smaller engine in the heart of Mars began to cool and sputter much more quickly. The story of the death of Mars is the story of a dying fire, of a fading planetary heartbeat. Deep in the center of a young living planet, a core of liquid iron churns and convects. This motion, combined with the planet's spin, generates a powerful global magnetic field. This is the planetary dynamo. This magnetic field is an invisible, silent, and absolutely essential shield. It extends far out into space, creating a protective bubble around the world, a force field called the magnetosphere. This shield is the first and most important line of defense against the constant violent assault of the Sun. But as the core of Mars began to cool, as the liquid iron began to solidify, and the churning motion slowed to a stop, the dynamo died. The planetary heartbeat faded into silence, and sometime around 4 billion years ago, the magnetic shield that had protected the young paradise simply vanished. The great force field fell, and in that moment, Mars was left naked and defenseless before the relentless fury of the solar wind. The solar wind is a constant invisible hurricane of charged particles, mostly protons and electrons, streaming away from the Sun at over 1 million miles per hour. For a protected planet like Earth, our magnetic shield deflects this hurricane, causing it to flow harmlessly around us. But the newly unprotected Mars had no such defense. The solar wind slammed directly into the upper layers of its thick, rich atmosphere. What followed was not a sudden explosive end, but a slow, silent, and agonizing death that took place over hundreds of millions of years. The process is known as atmospheric stripping. One by one, the energetic particles of the solar wind collided with the atoms and molecules of the Martian atmosphere, knocking them away into space with a gentle, persistent, and utterly relentless efficiency. It was the cosmic equivalent of a sandblaster, slowly and methodically stripping away the beautiful, life-sustaining shell of air. As the atmosphere was stripped away, molecule by molecule, the pressure at the surface of Mars began to drop. The thick, protective blanket of air grew thinner and thinner, and as the pressure fell, the great, liquid water oceans began to feel the effects. The boiling point of a liquid is dependent on the atmospheric pressure above it. The lower the pressure, the lower the temperature at which it boils. A surreal and terrible fate befell the Martian seas. Under a faint and distant sun, in a world that was growing colder, the oceans began to boil. The water did not boil from heat, but from the lack of pressure. The atmospheric lid was being removed from the pot, and the water simply evaporated away into the thin, dying air, where its molecules were then broken apart by solar radiation and carried away by the solar wind. A vast global ocean, larger than our Arctic, boiled away into the vacuum of space. The water that did not boil away was destined for a different, colder fate. As the greenhouse effect of the thinning atmosphere failed, the planet's temperature plummeted. The remaining water froze solid. Some of it was locked into the great polar ice caps we see today, a mixture of water ice and frozen carbon dioxide. But the vast majority of it is believed to have frozen into the ground itself, creating immense hidden glaciers of permafrost, miles thick, that may still be there today, a buried and frozen ghost of the lost ocean. The blue world became a red and white world, a planet of rust and ice, and then, over more eons, the relentless Martian winds covered most of that ice with the fine red dust, and it became the single-coloured desert world we know today. The transformation was complete. The paradise was lost. This great catastrophe, this planetary death, occurred in the deep past, between roughly 4 and 3.5 billion years ago. It happened during the very same period that the first simple microbial life was just beginning to take hold on Earth. The timing is the most tragic and the most profound part of this story. Mars had the first chance at life. It had a head start of hundreds of millions of years, but its window of opportunity, its beautiful blue Noachian spring, was a tragically short one. The cradle was perfect, but the cradle was destined to break. And so we are left with a dead world and a profound, haunting question. We know the cradle existed. We know it was a perfect and long-lived place for life to begin. We know it was there before the cradle of Earth was even ready. But we also know that this paradise was utterly and completely destroyed. This leads us to the very heart of the Mars origin hypothesis. If life did indeed begin in that brief, beautiful Martian spring, did it die with its world? Or in the final violent death throes of that planet, could some of that precious nascent life have found a way to escape? Could a piece of that lost paradise, a single living seed, have made the impossible journey across the void to a new, younger and more promising world that was just then beginning to cool? Could the story of life on Mars have an epilogue, written not in the red dust of a dead world, but in the living DNA of our own? On a Sunday afternoon on Earth, the air is a given. It is a thick, protective, life-sustaining ocean that we move through without a thought, its presence as constant and as reassuring as the solid ground beneath our feet. But the story of Mars's death is the story of how such a precious gift, the very breath of a world, can be lost, atom by atom, to the cold and unforgiving void. The catastrophe was not a single dramatic event, but a slow, creeping and inexorable decline, a planetary illness that took hundreds of millions of years to run its course. To understand this death, we have sent a detective, a robotic probe named MEVN, which stands for Mars Atmosphere and Volatile Evolution. Its sole purpose, its entire mission, is to orbit the red planet and to study the ghost of its atmosphere, to understand precisely how and why it vanished. MEVN has been our eye in the sky, watching the modern Martian atmosphere bleed away into space, and in doing so, it has given us the smoking gun, the definitive proof of how the ancient, thicker atmosphere was lost. The MEVN probe has dipped low into the upper reaches of the Martian air, and it has directly measured the particles that are being stripped away by the solar wind right now, today. It has tasted the dying breath of a world. Its instruments have confirmed that the solar wind is an incredibly efficient thief, carrying away tons of atmospheric gas every single day. And MEVN has also observed what happens during a solar storm, a great eruption from our sun. During these events, the rate of atmospheric loss increases dramatically, by a factor of 10 or even 20. This is the key. By measuring the rate of atmospheric loss today, and by understanding that our sun, in its youth, 4 billion years ago, was much more active and violent, prone to far more frequent and powerful solar storms, we can extrapolate back in time. The conclusion is stark. The young raging sun, in the absence of a protective magnetic field, would have stripped away a thick, Earth-like atmosphere from Mars with brutal and devastating efficiency. The data from MEVN is the forensic evidence that confirms the cause of death. Mars did not lose its atmosphere by chance, it was scoured away by its own star. As the atmosphere thinned, a catastrophic feedback loop began on the surface, a process that can be thought of as a runaway refrigerator effect. The thick carbon dioxide atmosphere of the Noachian period had acted as a warm blanket, trapping the sun's heat, but as that blanket was stripped away, the planet began to cool. As it cooled, more of the carbon dioxide in the atmosphere began to freeze, snowing down onto the polar caps to form the great deposits of dry ice we see today. But this freezing of carbon dioxide removed even more of the greenhouse gas from the atmosphere, which in turn made the blanket even thinner. This weaker greenhouse effect made the planet colder still, which caused even more carbon dioxide to freeze out of the air. It was a one-way trip to a deep freeze, a planetary death spiral from which there was no escape. The warmth bled away, the air turned to ice, and the planet was locked into a permanent frozen state. And what became of the water, the great blue life-giving oceans of the Noachian paradise? It suffered a twofold fate. Some of it was lost forever. High in the thinning atmosphere, the intense ultraviolet radiation from the sun, no longer blocked by a thick ozone layer, would have been powerful enough to split the water molecules, the HARVO, into their constituent parts, hydrogen and oxygen. Hydrogen, being the lightest of all elements, would have easily and quickly escaped the weak gravity of Mars, bleeding away into space. The oxygen, being heavier, would have been left behind, but it did not remain in the atmosphere. It was a highly reactive element, and it began to attack the iron-rich volcanic rocks on the surface. It caused them to rust. The planet-wide, uniform red color of Mars is the result of this great planetary scale oxidation. Mars is red because its ancient oceans rusted and its atmosphere was blown away into space. The very color of the planet is the color of its own death. But not all of the water was lost. A significant portion of it remains, hidden from view. As the planet froze, much of the water from the Northern Ocean and the Great Lakes would have seeped down into the ground, freezing into a thick, planet-spanning layer of permafrost. The ghost of the Martian Ocean is still there, not as a liquid, but as a vast, buried and deeply frozen glacier. Our orbiters have confirmed this with ground-penetrating radar. Instruments on probes like the Mars Express have peered deep beneath the dust, and they have detected what appear to be enormous, hidden deposits of pure water ice, just a few meters beneath the surface. In some places, these buried glaciers are thousands of feet thick and as large as the state of California. The water of the lost paradise is not entirely gone. It is merely in a deep, frozen and perhaps one day recoverable slumber. As the planet died, as the oceans vanished and the atmosphere was stripped away, the surface of Mars became the hostile, irradiated wasteland we see today. But could life have survived? Could there have been a last stand? If life had taken hold in the warm oceans of the Noachian, it would have been faced with a planetary scale extinction event. As the surface grew cold and was bathed in deadly radiation, life would have had to retreat. The last habitable niches on Mars would have been deep underground. Perhaps for a time life could have survived in deep geothermally heated aquifers, pockets of liquid water warmed by the last, fading heat of the planet's core. It is possible that in these deep, dark and hidden places, a simple microbial Martian biosphere could be clinging to existence. Even to this day, a secret shadow biosphere, entirely unaware of the dead and empty world on the surface above. We sometimes see tantalizing and deeply ambiguous hints of this hidden water, features known as recurring slope lining, dark streaks that appear on the sides of crater walls during the warmest months, were once thought to be the signature of modern flowing briny water. While this interpretation is now heavily debated, it is a reminder that the planet may not be entirely dormant. The possibility of small, isolated pockets of liquid water, even today, cannot be completely ruled out. The planetary catastrophe was absolute. The world that was once a cradle for life was transformed into a tomb. The surface was sterilized. The air was lost. The oceans were boiled away or frozen solid. Any life that had arisen in that brief, beautiful Martian spring was now faced with an ultimate and final test. a test of survival against the death of its entire world. The great overarching question of our story now becomes one of desperate cosmic escape. Could life, faced with a planetary apocalypse, find an ark? Could a dying planet, in its final violent death throes, send a message in a bottle, a single living seed, across the cold and empty sea of space? On a Sunday afternoon on Earth, the air is a given. It is a thick, protective and life-sustaining ocean that we move through without a thought, its presence as constant and as reassuring as the solid ground beneath our feet. But the story of Mars's death is the story of how such a precious gift, the very breath of a world, can be lost, atom by atom, to the cold and unforgiving void. The catastrophe was not a single dramatic event, but a slow, creeping and inexorable decline, a planetary illness that took hundreds of millions of years to run its course. To understand this death, we have sent a detective, a robotic probe named MAVEN, which stands for Mars Atmosphere and Volatile Evolution. Its sole purpose, its entire mission, is to orbit the red planet and to study the ghost of its atmosphere, to understand precisely how and why it vanished. MAVEN has been our eye in the sky, watching the modern Martian atmosphere bleed away into space, and in doing so, it has given us the smoking gun, the definitive proof of how the ancient, thicker atmosphere was lost. The MAVEN probe has dipped low into the upper reaches of the Martian air, and it has directly measured the particles that are being stripped away by the solar wind right now, today. It has tasted the dying breath of a world. Its instruments have confirmed that the solar wind is an incredibly efficient thief, carrying away tons of atmospheric gas every single day. And MAVEN has also observed what happens during a solar storm, a great eruption from our sun. During these events, the rate of atmospheric loss increases dramatically, by a factor of 10 or even 20. This is the key. By measuring the rate of atmospheric loss today, and by understanding that our sun, in its youth 4 billion years ago, was much more active and violent, prone to far more frequent and powerful solar storms, we can extrapolate back in time. The conclusion is stark. The young, raging sun, in the absence of a protective magnetic field, would have stripped away a thick, Earth-like atmosphere from Mars with brutal and devastating efficiency. The data from MAVEN is the forensic evidence that confirms the cause of death. Mars did not lose its atmosphere by chance. It was scoured away by its own star. As the atmosphere thinned, a catastrophic feedback loop began on the surface, a process that can be thought of as a runaway refrigerator effect. The thick carbon dioxide atmosphere of the Noachian period had acted as a warm blanket, trapping the sun's heat. But as that blanket was stripped away, the planet began to cool. As it cooled, more of the carbon dioxide in the atmosphere began to freeze, snowing down onto the polar caps to form the great deposits of dry ice we see today. But this freezing of carbon dioxide removed even more of the greenhouse gas from the atmosphere, which in turn made the blanket even thinner. This weaker greenhouse effect made the planet colder still, which caused even more carbon dioxide to freeze out of the air. It was a one-way trip to a deep freeze, a planetary death spiral from which there was no escape. The warmth bled away, the air turned to ice, and the planet was locked into a permanent frozen state. And what became of the water, the great blue life-giving oceans of the Noachian paradise? It suffered a twofold fate. Some of it was lost forever. High in the thinning atmosphere, the intense ultraviolet radiation from the sun, no longer blocked by a thick ozone layer, would have been powerful enough to split the water molecules, the HCO, into their constituent parts, hydrogen and oxygen. Hydrogen, being the lightest of all elements, would have easily and quickly escaped the weak gravity of Mars, bleeding away into space. The oxygen, being heavier, would have been left behind, but it did not remain in the atmosphere. It was a highly reactive element, and it began to attack the iron-rich volcanic rocks on the surface. It caused them to rust. The planet-wide, uniform red color of Mars is the result of this great planetary-scale oxidation. Mars is red because its ancient oceans rusted and its atmosphere was blown away into space. The very color of the planet is the color of its own death, but not all of the water was lost. A significant portion of it remains, hidden from view as the planet froze. Much of the water from the Northern Ocean and the Great Lakes would have seeped down into the ground, freezing into a thick, planet-spanning layer of permafrost. The ghost of the Martian Ocean is still there, not as a liquid, but as a vast, buried, and deeply frozen glacier. Our orbiters have confirmed this with ground-penetrating radar. Instruments on probes like the Mars Express have peered deep beneath the dust, and they have detected what appear to be enormous, hidden deposits of pure water ice just a few meters beneath the surface. In some places, these buried glaciers are thousands of feet thick and as large as the state of California. The water of the lost paradise is not entirely gone. It is merely in a deep frozen, and perhaps one day, recoverable slumber. As the planet died, as the oceans vanished and the atmosphere was stripped away, the surface of Mars became the hostile, irradiated wasteland we see today. But could life have survived? Could there have been a last stand? If life had taken hold in the warm oceans of the Noachian, it would have been faced with a planetary-scale extinction event. As the surface grew cold and was bathed in deadly radiation, life would have had to retreat. The last habitable niches on Mars would have been deep underground. Perhaps for a time, life could have survived in deep geothermally heated aquifers, pockets of liquid water warmed by the last fading heat of the planet's core. It is possible that in these deep, dark and hidden places, a simple microbial Martian biosphere could be clinging to existence, even to this day. A secret, shadow biosphere, entirely unaware of the dead and empty world on the surface above. We sometimes see tantalizing and deeply ambiguous hints of this hidden water, features known as recurring slope line, dark streaks that appear on the sides of crater walls during the warmest months, were once thought to be the signature of modern flowing briny water. While this interpretation is now heavily debated, it is a reminder that the planet may not be entirely dormant. The possibility of small, isolated pockets of liquid water, even today, cannot be completely ruled out. The planetary catastrophe was absolute. The world that was once a cradle for life was transformed into a tomb. The surface was sterilized, the air was lost, the oceans were boiled away or frozen solid. Any life that had arisen in that brief, beautiful Martian spring was now faced with an ultimate and final test, a test of survival against the death of its entire world. The great overarching question of our story now becomes one of desperate cosmic escape. Could life, faced with a planetary apocalypse, find an ark? Could a dying planet in its final violent death throes send a message in a bottle, a single living seed, across the cold and empty sea of space? On a Sunday afternoon, a time often for family and thoughts of home, we consider the most profound journey imaginable. Not a journey of a few miles or a few hours, but a journey of millions of years across millions of miles of cold, empty, and unforgiving space. We have told the story of a dying world. Now we will tell the story of a possible and perhaps necessary escape. This is the story of the cosmic arc. The theory that life can travel between planets is known as Panspermia. For a long time, it was considered a fringe idea, but our modern understanding of the solar system has shown it to be not only possible, but perhaps inevitable. The process is one of simple, powerful cosmic mechanics. Imagine the young Mars, even as it was dying, still being bombarded by the occasional large asteroid or comet. An impact of sufficient size would strike the planet with unimaginable force. This force would blast a crater into the Martian surface, but it would also eject a vast plume of rock and debris high above the thin atmosphere and out into space. Some of this debris would be launched with such velocity that it would escape the weak gravity of Mars entirely, beginning a new life as a tiny tumbling moonlet in orbit around the Sun. This is the first step of the journey, the escape. For thousands, or even millions of years, these ejected Martian rocks would travel through the void. They would be exposed to the harsh vacuum of space, to the extreme cold, and to the constant sterilizing bath of solar and cosmic radiation. On the surface, any life would surely perish, but deep within the rock, sheltered by just a few inches of stone, the conditions would be different. The cold would be a perfect form of preservation, and the rock itself would act as a shield, protecting any microbial stowaways from the worst of the radiation. The final step of the journey is the arrival. The solar system is a busy, chaotic place. The orbits of these Martian rocks would, over the eons, be gently nudged and pulled by the gravity of the planets. Eventually, by pure chance, the orbit of one of these rocks would intersect with the orbit of another, much larger, much more promising world, a young, blue, and newly habitable planet Earth. Pulled in by Earth's gravity, the Martian rock would plunge into our thick atmosphere at tens of thousands of miles per hour. It would glow with the heat of friction, becoming a brilliant meteor, a shooting star in the sky of a world that had no eyes to see it. If the rock was large enough, it would survive this fiery descent, and it would crash upon the surface, or into the oceans of the young Earth, ending its long journey and delivering its precious cargo. This is not just a theory. We know with absolute certainty that this interplanetary pathway is real. We know this because we have found the messengers here on Earth in the most pristine and ancient landscapes, like the great white deserts of Antarctica. We have found meteorites, rocks that have fallen from the sky, that are not from our own world. These are the SNC meteorites, Shergottites, Naklites, and Chassignites. For decades, scientists suspected they were from Mars, but the proof came in the 1980s. Inside tiny glassy pockets within these meteorites, forever sealed during the shock of their ejection from Mars, scientists found trapped bubbles of gas, and when they analyzed this gas, they found it was a perfect match, a chemical fingerprint, for the atmosphere of Mars as it was measured by our Viking landers in 1976. This was the smoking gun, a piece of the Martian sky, trapped in a Martian rock that had journeyed for millions of years and had landed here on Earth. The pathway is real. The cosmic arcs exist. This leads us to one of the most famous and controversial meteorites ever discovered, Allen Hills 84001. Found in the Allen Hills of Antarctica in 1984, it was just another unassuming greenish-grey rock among many. But this rock was special. It is one of the oldest pieces of the solar system we have ever held, a piece of the ancient Noachian crust of Mars, from the very time that the planet was a warm and wet paradise. And deep within it, scientists found something that would shake the world. In 1996, a team from NASA held a press conference that was broadcast globally. They announced that they had found several lines of evidence inside ALH 84001, pointed to the existence of ancient fossilized microbial life from Mars. The world was stunned. The evidence was tantalizing. They had found complex organic molecules called polycyclic aromatic hydrocarbons, the greasy soot of life, deep within the rock. They had found tiny grains of the mineral magnetite, of a specific shape and purity that on Earth is only produced by certain types of bacteria, and most famously, they had put the rock under an electron microscope and had found small, segmented, worm-like shapes that looked, for all the world, like the fossilized remains of ancient nanobacteria. A fierce and passionate scientific debate immediately erupted, and it continues to this day. Skeptics, and the majority of the scientific community, have argued that each of these lines of evidence can also be explained by non-biological geological processes. The organic molecules could have formed through natural chemistry. The magnetite grains could have been created by the shock of the impact that launched the rock, and the tiny worm-like shapes, the fossils, could simply be strangely shaped mineral deposits, a trick of light and shadow on a microscopic scale. The debate is unresolved. ALI 84001 did not provide the definitive proof of life on Mars that the world had hoped for, but it did something arguably more important. It proved that the question of life on Mars was a serious and valid scientific pursuit. It proved that the building blocks of life could be found in Martian rocks, and it proved, without a shadow of a doubt, that these rocks, these potential arcs, have been making the journey from Mars to Earth for billions of years. And so we must assemble the pieces of our story so far. We know that Mars, in its ancient Noachian past, was a warm, wet, and perfectly habitable world. We know that this paradise existed for hundreds of millions of years, long before Earth was cool enough to support life. It had the head start. We know that there is a natural, functioning, and constantly operating pathway that transports rocks from the surface of Mars to the surface of the Earth. We know that simple microbial life is incredibly resilient and could likely survive the long journey, shielded inside one of these rocks. The final, profound implication is now unavoidable. The story of life on Earth may not have begun in the oceans of our own world. It may have begun in a splash of Martian water, and then facing the great planetary catastrophe of a dying world, that life found an arc. It made the impossible journey, and it seeded a new, younger, and more promising garden. If this is true, then our entire family tree, every plant, every animal, every living thing on this planet, has its deepest, most ancient roots in the red soil of a lost sibling world. We are the children of Mars. This raises the next, and perhaps most startling question in our journey. If simple microbial life made the journey, what if something more complex arose on Mars in the billion years it had before Earth was even ready? What if we are not the first civilization in this solar system? On a quiet Sunday on Earth, life can feel secure, a thing rooted to the soil and the sea of a single world. But the story of Panspermia, the story of life traveling between the stars, is not a gentle one. It does not begin with a calm departure. It is a story that begins with an act of unimaginable violence, cosmic explosion that turns a piece of one world into a potential ark for another, a desperate message in a bottle thrown into the great dark ocean of space. To understand how life could escape a dying Mars, we must first understand the mechanics of the ejection. Imagine the young Mars, even 4 billion years ago, a world with a thinning but still present atmosphere. A large asteroid, perhaps miles in diameter, strikes the surface. The impact releases more energy than all the nuclear weapons on Earth combined. But the key to seeding life is not just the power of the impact, but its nature, a process known as spallation. The immense shockwave from the impact does not just create a crater, it travels through the crust of the planet like a ripple in a pond. When this shockwave reaches the surface on the other side of the planet, or even just far from the impact site, it can literally pop a chunk of the planet's surface off into space. The beauty of this process is that the ejected rock itself is not superheated. It is accelerated to escape velocity through shock, not through heat. This is crucial. It means that the interior of that rock can remain cold, sheltering any microscopic organisms, any microbial stowaways, from the incandescent heat of the initial impact. The impact must be a Goldilocks event, too small, and the debris will not reach escape velocity. It will simply fall back to the surface, too large, and the energy released would be so great that it would sterilize the entire region, vaporizing the very rocks that would have served as arcs. It requires a specific set of circumstances, a collision of just the right size and angle, but in the chaotic and violent early solar system, such impacts were not rare. They were a common occurrence. The launching of these rocky arcs from the Martian shore would have been a regular, if catastrophic, event. Once launched, the arc begins its true journey, a long and perilous gauntlet through the interplanetary void. The challenges to life are immense. The first is the vacuum of space, which would instantly boil away any exposed water. But we know from life on Earth that microbes, when faced with such conditions, can enter a state of deep suspended animation, a process called cryptobiosis. They can dehydrate themselves completely, shut down all their metabolic processes, and become, for all intents and purposes, tiny, dormant, and almost indestructible specks of potential. The second great challenge is the radiation. The space between the planets is flooded with a constant, invisible storm of high-energy particles. There are the charged particles of the solar wind, and even more dangerous, the galactic cosmic rays, or GCRs. These are the nuclei of atoms, fired from distant, exploding supernova, traveling at nearly the speed of light. A direct hit from one of these particles can shred a strand of DNA, causing lethal mutations. For a microbe on the surface of the rock, the journey would be a sentence of death. There's just a few inches inside the rock, the story changes. The stone itself acts as a radiation shield. It absorbs the majority of the solar wind and a significant portion of the less energetic cosmic rays. It is not a perfect shield. The most powerful GCRs can still penetrate deep into the rock, but it dramatically increases the odds of survival. The arc provides a haven. The length of the journey is also a critical factor. The orbits of Martian rocks are chaotic and unpredictable. Some, by a lucky fluke of celestial mechanics, might make the journey from Mars to Earth in just a few thousand years. Others might travel for much longer. The famous Martian meteorite, ALH 84001, is estimated to have been in space for over 15 million years before it finally fell on Antarctica. The longer the journey, the more radiation the microbial passengers would have to endure, and the lower their chances of survival. But with millions of tons of Martian rock being ejected over the planet's history, it only takes one fast-track journey, one lucky arc. After its long, cold, and silent voyage, the arc faces its final trial, the fiery plunge through Earth's atmosphere. An object entering our atmosphere from space is traveling at tens of thousands of miles per hour. The friction with the air heats its surface to thousands of degrees, creating the brilliant, glowing trail of a meteor. But this process of burning, called ablation, is also a form of protection. As the outer layers of the meteorite vaporize, they carry away most of the heat, acting as a natural ablative heat shield. This process protects the interior of the rock from the most extreme temperatures. While the outside glows white-hot, the very center of the rock can remain frozen. For a rock of a sufficient size, something larger than a basketball, it is entirely possible for it to survive the plunge, crash land on the surface, and for its interior to have never been heated enough to sterilize it. This entire incredible sequence of events, the violent but cool ejection, the dormant journey through shielded space, and the fiery but survivable atmospheric entry makes the transfer of life from Mars to Earth a scientifically plausible pathway. The bridge between the two worlds is real. The question is, did anything ever cross it? This brings us back to the great debate surrounding Allen Hill's 84001. The NASA team's 1996 announcement was met with a wave of intense scrutiny from the scientific community, as it should have been. Extraordinary claims require extraordinary evidence, and over the following years, skeptical scientists put forward strong, non-biological explanations for every line of evidence that had been presented. The complex organic molecules, the PAHs, could have been the result of terrestrial contamination after the rock had landed in Antarctica, or they could have been formed through simple, natural, non-living chemical reactions on ancient Mars. The strange teardrop-shaped carbonate globules could have been formed by the high temperatures and pressures of a shock event, like the impact that blasted the rock off of Mars in the first place. The tiny, perfectly formed magnetite grains, which looked so much like those produced by bacteria, could also have been formed in the heat of that same shock event, a process that has been replicated in laboratories. And the most famous piece of evidence, the tiny worm-like shapes that looked so much like fossilized microbes, were orders of magnitude smaller than any known cellular life on Earth. Most scientists now believe that these are likely just unusual, but entirely natural, mineral formations, are pattern-seeking human brains seeing a familiar shape where none truly exists. So the case for life in ALH 84001 is not a closed one in the eyes of most of the scientific community. The evidence has been found wanting. There is no smoking gun in that rock, but the true legacy of ALH 84001 was not in the answers it failed to provide, but in the profound questions it forced us to ask. It took the idea of panspermia from the realm of fringe speculation and placed it firmly on the table of mainstream legitimate scientific inquiry. It ignited a new wave of research into astrobiology and the search for life, not just on other worlds, but in the very rocks that fall to our own. The bridge between the two worlds is real. The arcs are proven to exist, and to make the journey, the survival of the simplest forms of life on that journey is plausible. The transfer of life from the first habitable world in our solar system to the second is therefore not just a wild theory. It is a scientifically coherent, deeply compelling, and wonderfully elegant possibility. The question is no longer could it have happened. The question we are now faced with is, did it happen? And if it did the story of Martian life stop there, with the transfer of a few hardy microbes, or did something more profound, more complex, have time to arise in the long, quiet spring of that first paradise? We have now arrived at the deepest and most provocative question in our story. We have established that ancient Mars was a paradise. We have described its tragic death, and we have proven that a bridge, a pathway for life to travel, exists between that world and our own. We are now forced to ask the final and most profound question of the Martian past. What if something more than just microbes grew in that ancient garden before the long winter came? The idea is a staggering one. If Mars was habitable for up to 1 billion years before Earth was, what might have happened in that immense span of time? On Earth, the first 1 billion years of life were a slow microbial process, but we cannot assume the timeline would be the same on another world. Given that profound head start, is it possible that life on Mars evolved beyond the microscopic stage? Could it have become complex? Could it have become intelligent? Could it have built a civilization, a technological society that rose and fell millions or even billions of years before the first multicellular life ever appeared on Earth? What if we are not the first? This is the Mars origin hypothesis in its fullest and most breathtaking form. Not just that our biology came from Mars, but that our very concept of civilization is not the first in this solar system. To even begin to explore this question, we must first understand the immense crushing scale of geological time. A civilization, even one that lasts for 10,000 years, is a fleeting whisper in the 4.5 billion year history of a planet. It is a single page in a library of 4 million books. After 65 million years on Earth, all that is left of the mighty Tyrannosaurus Rex are a few scattered bones. What would be left of a city, of a machine, of a civilization, after a billion years of cosmic radiation, of erosion and of silence? We should not be looking for ruined cities on the surface of Mars. The winds and the dust of eons would have ground them down to nothing. We must look for something more subtle, more enduring. We must look for the faint, ghostly fingerprints that a technological civilization might leave behind in the very rock and atmosphere of a planet. We must search for its techno-signatures. The search begins with the atmosphere, the thin, ghostly remnant of what was once a great ocean of air. Are there any strange traces, any chemical ghosts left behind? One of the most enduring mysteries of the modern Martian atmosphere is the unexplained presence of methane. On Earth, the vast majority of methane is produced by living organisms. On Mars, we detect plumes of this gas, appearing and disappearing with the seasons, and we do not know where it is coming from. It could be the result of a simple geological process we don't yet understand, or, some have speculated, it could be the final, faint exhalation of a deep subsurface microbial biosphere, the last survivors of the Great Catastrophe. But could it also be the slow, steady leak from the decaying ruins of a buried ancient industrial civilization? The more profound clues, however, would lie in the geology. Any industrial civilization must mine, process, and discard materials. These activities would inevitably leave behind unnatural concentrations of minerals and elements. Our rovers, like Curiosity and Perseverance, are not just cameras on wheels, they are mobile geological laboratories. As they analyze the Martian rock, they are searching for these very anomalies, a strange localized deposit of rare earth elements, or a vein of purified metals, could be the faint billion-year-old trace of an ancient mining operation. A single, microscopic fragment of a synthetic polymer, a piece of ancient plastic, buried in a layer of mudstone, would be a discovery that would change the world forever. Then there is the possibility of a much more dramatic signature, a nuclear one. A controversial but deeply compelling theory put forward by physicist Dr. John Brandenburg suggests that a Martian civilization did exist, and that it was wiped out by a planet-shattering nuclear event. He points to several lines of evidence. The first is the concentration of a particular isotope, xenon-129, in the Martian atmosphere. Its abundance on Mars is far higher than on Earth, or anywhere else in the solar system, and a high concentration of xenon-129 is a known signature of a large-scale nuclear fission event, the kind produced by nuclear weapons. He also points to data from our orbiters, which show two great hotspots of radioactivity on the Martian surface, one in the region of Acidalia Planitia and another in Utopia Planitia. These regions have unusually high concentrations of the radioactive elements thorium and potassium, which are not concentrated in the same way elsewhere on the planet. Brandenburg argues that these are the sites of two immense airborne nuclear explosions that occurred in the distant past, creating a global radiological catastrophe that sterilized the planet and helped to blow its atmosphere away into space. Whether this event was an act of planetary scale warfare, a Martian civilization destroying itself, or an attack from an outside force, the theory is a chilling one. It seeks to explain not only the existence of a past civilization, but also its sudden and total disappearance. It suggests that the death of Mars was not just a slow natural decline, but a violent, artificial, and tragic murder. The search for a lost Martian civilization is now a real, if unspoken, part of our exploration of the Red Planet. We are no longer just looking for the fossilized remains of simple microbial life. We are now searching for the faint, ghostly echoes of a mind, of a civilization, of a forgotten chapter of the story of intelligence in our solar system. And some believe that the echoes of that lost world are not just hidden in the chemistry of the rocks and the air, but have been staring right at us in the strange and unsettling geography of Mars itself. The very idea of a lost technological civilization on Mars forces us to confront a profound philosophical challenge. How do you search for something when you do not know what it looks like? Our entire understanding of technology, of industry, of civilization is based on a single data point: ourselves. We look for the signatures that our own civilization would produce, the plastics, the pollutants, the radioactive isotopes. This is a necessary, but perhaps limiting starting point. An ancient Martian civilization, with a different biology, a different chemistry, and a billion-year head start, may have developed a technological base that is utterly alien to our own. Their industry may not have been based on combustion, but on geothermal or gravitational energy. Their building materials may not have been concrete and steel, but biologically grown, self-repairing structures. Their waste products may not have been the long-chain polymers of our plastics, but something far more exotic, or perhaps something perfectly biodegradable and leaving no trace at all. The search for their techno-signatures is therefore a search for an anomaly, a deviation from the natural baseline of Mars, whatever that baseline may be. It is the ultimate forensic investigation. Let us look again at the atmospheric evidence. The methane plumes are a tantalizing mystery, but there are other, more subtle clues we could search for. On Earth, our industrial revolution has flooded the atmosphere with synthetic molecules that do not exist in nature, compounds like chlorofluorocarbons or CFCs. These are undeniable techno-signatures. While these specific compounds would break down over millions of years, they would leave behind telltale daughter products, specific isotopes of chlorine and fluorine that could become trapped in the Martian polar ice caps. A core sample from the Martian poles containing a layer with an unnatural concentration of these elements could be a definitive sign of ancient industry. This is the power of isotopic analysis. An element like carbon comes in different weights or isotopes. Nature produces these isotopes in very predictable and stable ratios. The carbon in a volcanic eruption has a different isotopic signature than the carbon released from burning a fossil fuel, and the carbon used in industrial processes can have a different signature still. Technology, especially nuclear technology, changes these natural ratios in ways that nature cannot replicate. It is a fingerprint that cannot be erased by time. The high concentration of xenon-129 is one such alleged fingerprint. The ongoing search is for others, hidden in the thin air or trapped in the ancient ice. The geology of Mars offers an even richer library of potential clues. We can search for the ghost of an ore body. On Earth, mining operations leave behind unmistakable signs. We take a resource that is thinly distributed, like copper or iron ore, and we concentrate it, purify it, and use it. An ancient Martian mining operation would have done the same. Our orbiters are equipped with powerful spectrometers that can map the mineral composition of the surface. The discovery of a vein of unnaturally pure titanium, or a region that has been completely stripped of a specific resource in a way that defies natural erosion, could be the silent geological scar of an ancient industrial project. An advanced global civilization would also likely leave behind a thin but planet-wide layer in the geological record. Just as the asteroid that killed the dinosaurs left a global layer of iridium, our own industrial age is creating a layer of microplastics and fly ash that will be visible to geologists millions of years from now. Our rovers, as they drill into the sedimentary layers of ancient Martian lake beds, are in effect reading the pages of a history book written in stone, the discovery of a single thin layer in that rock, a layer containing anomalous metals, synthetic compounds, or isotopic ratios that are out of place, would be the discovery of a lost chapter of that history. It would be the fingerprint of a Martian Anthropocene, a lost age when a different intelligence held dominion over the red planet. We can also search for the lingering heat of a lost civilization. Any technological society must produce and consume vast amounts of energy, and according to the laws of thermodynamics, all energy use ultimately degrades into waste heat. A massive buried city or a great subterranean power plant, even after millions of years of decay, might still be releasing a faint residual heat signature. Our orbiters can map the surface temperature of Mars with incredible precision. The discovery of a geothermal hotspot, an area that is unaccountably warmer than the surrounding terrain, could be a sign that we have found the grave of a city or the slowly cooling embers of a power source built by a long-vanished hand. Conversely, what if they use solar power on a massive scale? Imagine great, continent-spanning solar farms designed to power their world. Over billions of years, the structures themselves would be gone. But what might they leave behind? Perhaps the intense, concentrated sunlight would have melted the surface of the Martian desert, leaving behind vast, thin sheets of fused silica, of glass. A great, unnatural, glassy plain in the middle of a Martian desert could be the faint, weathered footprint of a colossal ancient power station. The search for these subtle, chemical and geological fingerprints is a patient and meticulous one. It is a search for a needle of artificiality in a haystack the size of a planet, but it is a necessary one. It is the scientific bedrock of this incredible hypothesis, the attempt to move the idea from the realm of speculation into the realm of testable forensic science. Yet, while some scientists look through microscopes and spectrometers for these faint chemical traces, others have been looking at the grand, sweeping photographs of the Martian surface, and they believe that the evidence is not subtle at all. They believe it is monumental and has been hiding in plain sight for decades. The search for a lost Martian civilization is not confined to the microscopic world of chemistry and isotopes. For decades, some researchers have argued that the evidence is not subtle at all, but is instead monumental, carved into the very face of the planet, hiding in plain sight. They suggest that while the faint chemical traces are the pages of the story, the great strange structures on the surface are the cover of the book, a cover that has been staring at us for half a century. Our journey now takes us to a specific region of the Martian northern hemisphere, a place of flat plains and weathered mesas, a place called Cydonia. It was here, in the year 1976, that the Viking 1 orbiter, one of humanity's first great emissaries to the Red Planet, was mapping the surface, looking for potential landing sites for its sister craft. It took thousands of photographs, routine images of a cratered and alien landscape. But one of those photographs, image number 35A72, was anything but routine. When the image was transmitted back to Earth, a technician at the Jet Propulsion Laboratory saw something that should not have been there. Lying amongst the weathered mesas and craters of Cydonia was a feature that looked unmistakably like a human face. It was nearly 2 miles long, with what appeared to be 2 eyes, a nose, a mouth, and a kind of helmet or headdress. It was a haunting humanoid visage, staring silently up into the blackness of the Martian sky. The initial reaction from the scientific team at NASA was one of amused dismissal. They released the image to the public, labeling it as a simple trick of light and shadow, a natural landform that just happened to look like a face from that specific angle and time of day. It was a classic case of what is known as pareidolia, the human brain's innate tendency to see familiar patterns, especially faces, in random arrangements of objects. It was, they assured the world, a geological ink blot test, but the image, once released, took on a life of its own. It captured the public imagination in a way that no dry scientific data ever could. It became an icon, a symbol of the profound mysteries of the Red Planet, and a small group of independent researchers refused to accept the official explanation. They argued that the face on Mars was not just a trick of the light. They believed it was an artificial structure, a colossal monument, a piece of sculpture built on a planetary scale. These researchers, led by figures like Richard C. Hoagland, were not content with just the face. They began to analyze the other Viking photographs of the Cydonia region, and they claimed to have found not just one monument, but an entire complex of artificial structures. They argued that the face was the centerpiece of a vast ruined city, a Martian Giza, with its own collection of pyramids and temples. Just a few miles from the face, they identified a cluster of features they called the city. It was a group of messes that showed an unusually geometric, almost crystalline structure, with straight lines and sharp angles that were unlike the natural eroded terrain surrounding them. Nearby stood another feature they dubbed the fort, a structure with two perfectly straight, 90-degree edges, and most impressively, there was the Den Dem Pyramid, named after its discoverers. This was an immense five-sided pyramidal structure with what appeared to be a radial symmetry, a form that seemed to defy natural geology. The proponents of this theory went even further. They began to perform complex mathematical and geometric analyses of the relative positions and orientations of these structures. They claimed to have found a deliberate and highly sophisticated mathematical code embedded in the layout of the Cydonia complex, a set of repeating angles and mathematical constants that suggested the entire area had been designed with a specific and intelligent purpose. Cydonia, they argued, was not a random collection of hills. It was a message written in the language of mathematics and sacred geometry, a message left for us to one day discover and decode. For over 20 years, this debate raged. The official scientific community continued to dismiss the claims as pseudoscience, a classic case of people seeing what they wanted to see. The proponents continued to publish their work, accusing NASA of a cover-up, of deliberately hiding the truth of an ancient Martian civilization. The face on Mars became a symbol of this deep divide, a battleground between mainstream science and the tantalizing pull of a world-altering possibility. Then in 1998, and again in 2001, a new generation of orbiters, the Mars Global Surveyor, arrived at the Red Planet, equipped with cameras far more powerful than those on the old Viking craft. NASA deliberately targeted the Cydonia region, with the stated goal of settling the question once and for all. The new high-resolution images were taken and released to the world. These new photographs showed the face in stunning, crisp detail, and what they revealed was a heavily eroded, natural-looking mesa. The features that had looked so much like eyes, a nose and a mouth in the grainy, low-resolution Viking image, were now revealed to be a collection of hills, ridges, and shadows. For the vast majority of the scientific community, and for the public, this was the final word. The face on Mars was, as NASA had said all along, a trick of the light, a geological coincidence. The case was closed. But for the most ardent believers, the new images were not the end of the story. They argued that the structure was still clearly artificial, even if it was ancient and deeply eroded. They claimed that the new images were taken under different lighting conditions that obscured its most face-like features. They pointed to the continued symmetry of the landform as evidence of a non-natural origin, and most importantly, they argued that the debunking of the face as a perfect sculpture did not explain the other strange geometric anomalies in the Cydonia region, like the five-sided D and M pyramid, which remained as mysterious as ever. The mystery of Cydonia is not the only case of a strange monumental object on the Martian surface. As our orbiters have continued to map the planet, they have captured other, equally unsettling images. One of the most famous is the Martian monolith. Photographed by the Mars Reconnaissance Orbiter, it is a single large rectangular object, a geometric shape that appears to be standing upright on the Martian plains, casting a long dark shadow. It looks for all the world like an artificial stone pillar. It is most likely a large, unusually shaped boulder, but its stark geometry, in the middle of a flat and otherwise featureless landscape, is deeply intriguing. Other, more controversial images have been pointed to as evidence of ruined infrastructure. Some photographs appear to show vast, translucent, tube-like structures, some of them broken and fragmented, crisscrossing the Martian surface. Proponents have claimed that these are the remains of ancient transportation tubes or great aqueducts, now covered in a thick layer of dust, their glassy forms still visible from orbit. And the images from our rovers on the ground have added their own rich library of anomalies. In the sea of countless rocks and pebbles that the rovers have photographed, people have seen shapes that look like a human thigh bone, a cannonball, an iguana, or even a ghostly woman. These are almost certainly cases of pareidolia, the mind's trick of seeing the familiar in the random. But they are a symptom of a deep and powerful human yearning, the yearning to find something recognizable, something we can connect with, in that vast and alien landscape. We are so desperate to not be alone, that we are willing to see a face, a bone, or a friend in any passing shadow. These great visual anomalies of the Martian surface exist in a profound and fascinating grey area. They are the borderlands between hard geology and speculative archaeology, between a trick of the light and a potential world-altering truth. They are not definitive proof of a lost civilization, but they are a haunting and persistent reminder that this ancient neighbouring world is still full of deep and unanswered questions. The faint chemical and geological techno-signatures may be the scientific foundation of the hypothesis, but these grand, strange and monumental images are its soul. They are the echoes that speak not to our instruments, but directly to our imagination. The ruins on Mars, whether they are the real eroded remains of an ancient city or simply tricks of light and shadow on a weathered landscape, force us to ask the most chilling question of all. If we are not the first, if a technological civilization truly did rise and fall on our neighbouring world, then where are they? Their utter and complete absence is a mystery as profound as their potential existence. This silence, this planetary ghost, is a direct confrontation with one of the most sobering and powerful concepts in all of cosmology, the Great Filter. To understand this idea, we must first return to the great cosmic question, the Fermi paradox. The universe is ancient and incomprehensibly vast. Our own galaxy contains hundreds of billions of stars, many of which are billions of years older than our Sun. Logic suggests that life should have arisen on countless worlds, and that some of that life should have evolved into intelligent, star-faring civilizations. Our galaxy should be teeming with the signs of their existence, a vibrant and noisy metropolis of light and information. Yet, when we listen, all we hear is a deep and profound silence. The paradox is simple. The universe should be full, but it appears to be empty. Where is everybody? The Great Filter is a potential answer to that question. It is a hypothesis that suggests that somewhere on the long, arduous, evolutionary path from the first spark of simple life to a galaxy-spanning super-advanced civilization, there is a barrier, a great wall, a filter that is so difficult to overcome that almost no species anywhere in the universe ever makes it through. It is the great destroyer of civilizations, the reason the cosmos is so silent. It is the universal challenge that sorts the living from the dead. The most profound and urgent question for humanity is this: where in the long sequence of life's evolution does this great filter lie? Is it behind us, or is it ahead of us? If the filter is behind us, then we are one of the luckiest, and perhaps one of the first species in the entire galaxy. This is the hopeful possibility. It would mean that one of the steps we have already passed was the great universal challenge. Perhaps the filter is the initial spark of life itself, a chemical miracle so improbable that it has almost never happened anywhere else. Or perhaps it is the leap from simple prokaryotic cells to complex eukaryotic ones. Or perhaps it is the evolution of intelligence and consciousness, a fluke of development that is incredibly rare. If any of these are true, then the silence we hear is the silence of an empty universe, and we are its first true voice. But there is another, far more terrifying possibility, that the filter is not behind us, but is waiting for us, somewhere in our future. This would mean that the emergence of life, and even of technological intelligence like our own, is a common and unremarkable event in the cosmos. The universe could be filled with countless young, hopeful civilizations, just like our own, all broadcasting their presence into the night, all dreaming of the stars, but none of them last. They all, without exception, reach a certain point, a certain technological or social challenge, and they all fail. They all destroy themselves. The silence in this view is not the sound of an empty universe. It is the sound of a cosmic graveyard. This is where the ghost of a lost Martian civilization becomes so much more than just a fascinating theory. It becomes a case study, a piece of evidence, a silent and chilling testament that a civilization right here in our own solar system may have reached the great filter and failed to pass through. What could have been the Martian filter? One possibility is that it was a natural one. We have already told the story of the Great Catastrophe, the slow death of the planet's magnetic field and the stripping of its atmosphere. Perhaps this was it. Perhaps the Great Filter is a planetary event, a change in a world's habitability that is so profound that no civilization, no matter how advanced, can stop it. The Martian civilization may have seen it coming. They may have had geologists and climatologists who warned them, who plotted the slow decay of their magnetic shield and the thinning of their air. Imagine the great, planet-wide projects they may have undertaken to try and save their world. They may have built immense atmospheric processors. They may have tried to jumpstart their planet's core. They may have constructed great, sealed habitats to try and ride out the storm. But in the end, the slow, inexorable forces of cosmic mechanics were simply too powerful. Their world died, and they died with it. Their failure would be a terrifying lesson that a civilization is ultimately a prisoner of its planet's life cycle, and that all paradises are in the end temporary. But there is a darker and more immediate warning in the story of Mars. What if the filter was not a natural event, but a self-imposed one? What if the Martians did not have their world taken from them, but destroyed it themselves? This brings us back to the chilling hypothesis of a planetary nuclear war. The Great Filter could be the discovery of nuclear weapons. Perhaps every intelligent species, upon unlocking the incredible power hidden within the atom, inevitably and tragically turns that power upon itself. The same intelligence that allows for the discovery of physics may be inextricably linked to the tribalism and aggression that leads to war. The high concentrations of xenon 129 in the Martian atmosphere would then be the last fading radioactive scream of a civilization that failed this great universal test. Or perhaps their self-destruction was a slower, more insidious process. A filter that is all too familiar to us today. Perhaps the Martian civilization discovered and began to burn their own planet's fossil fuels. Their industry would have grown, their technology would have advanced, but all the while, they would have been changing their own climate, polluting their own atmosphere, and triggering a runaway greenhouse effect that their science in the end could not reverse. Their fall would have been a slow, agonizing one. A story of rising temperatures, of melting ice caps, of dying oceans, and of a society that was unable or unwilling to change its ways before it was too late. The dead, dry, carbon dioxide-rich world of Mars would not just be the ghost of a lost paradise. It would be the ghost of a civilization that committed planetary suicide, a civilization that grew so powerful that it became a geological force, and in doing so engineered its own extinction. There are other, more exotic possibilities. The Great Filter could be the invention of a technology that we have not yet encountered. Perhaps it is the creation of a superintelligent artificial intelligence, a mind so powerful that it immediately transcends the control of its biological creators and eliminates them as either a threat or an irrelevance. The silence from Mars could be the silence of a planet that is now run by, and for, a machine intelligence that has no interest in communicating with the noisy biological upstarts on its neighboring world. The ghost of Mars, therefore, presents us with a profound and deeply urgent warning. Its silent, frozen surface is a vision of a possible future, a silent testament to a civilization that may have reached the Great Filter and failed to pass through. The red planet is a cosmic memento mori, a skull on the desk of humanity, a constant and humbling reminder of our own fragility. But it may also be something more. It may not just be a warning from a lost civilization. It may be a warning from our own long-lost ancestors. The ghost of Mars presents us with a profound and urgent warning. It is a vision of a possible future, a silent testament to a civilization that may have reached the Great Filter and failed to pass through. The red planet is a cosmic memento mori, a skull on the desk of humanity, a constant and humbling reminder of our own fragility. But to truly understand the weight of this warning, we must look deeper at the nature of the filter itself. It may not be a single dramatic event, but a long and treacherous path, lined with a series of hurdles, any one of which could be fatal. The journey from a sterile, rocky world to a galaxy-spanning intelligence is a long one. The first great hurdle is the origin of life itself. The jump from non-living chemistry to the first simple, self-replicating cell may be a step of such staggering improbability that it has almost never happened anywhere else in the cosmos. If this is the Great Filter, then we, and the ancient Martians, are the products of an almost unique miracle. The next filter could be the leap from simple prokaryotic life to complex eukaryotic life, the development of the cellular machinery that allows for true complexity. Another could be the jump to multicellularity, the moment when single cells learn to cooperate and build a larger organism. Then comes the hurdle of intelligence, the evolution of a brain capable of abstract thought, of tool use, of understanding the laws of the universe. Each of these steps is a profound and perhaps incredibly rare event. If the filter lies at any of these early stages, then the silence in the universe is the silence of a cosmos that is largely barren of complex life. We would be one of the very few, if not the only, species to have made it this far. This is the hopeful interpretation, the idea known as the rare Earth hypothesis. It suggests that a planet like ours, with a large stabilizing moon, with a system of plate tectonics to regulate its climate, with a powerful magnetic field, and with a protective gas giant like Jupiter in its outer solar system, is an almost impossibly rare configuration of events. In this view, Mars is not a tragic failure. It is the normal outcome for a rocky planet. It had a brief, habitable spring, and then it died. Earth, with its long, stable, multi-billion-year habitability, is the true miracle, the great exception to the cosmic rule. But what if this is not the case? What if habitable, Earth-like worlds are common? What if the evolution of complex, intelligent life is a routine and unremarkable outcome of the universe's laws? If that is true, then the great filter cannot be behind us. It must, by grim necessity, be in front of us, and the story of Mars becomes a terrifying case study of what that filter might be. Let us imagine the final days of a hypothetical Martian civilization as they face their filter. Imagine their scientists drilling ice cores and analyzing atmospheric data, discovering the terrible truth their planet's core was cooling, their magnetic shield was failing, and their world was slowly bleeding out into space. Imagine the global panic, the political debates, the desperate, planet-wide effort to find a solution. They would have been a civilization far more advanced than our own, but even their great technology may not have been enough to restart the heart of a dying planet. In their final years, what would they have done? Would they have tried to build great subterranean arcs to ride out the long winter? Places where their descendants may have survived for a time before finally succumbing to the cold? Would they have tried to launch great starships to escape to another world, a desperate, multi-generational voyage that may have failed in the vastness of the interstellar dark? Or, knowing that their own civilization was doomed, would they have turned their final efforts to preserving life itself? Would they have looked across the void to the younger, more promising blue world of Earth and decided to seed it? The theory of directed panspermia, in this context, is not an act of cosmic gardening, but an act of desperate parental sacrifice, the last act of a dying civilization to ensure that their children, the simple microbes carrying their genetic legacy, would have a chance to survive on a new world. There is another, even darker possibility to consider. The great filter may not be a natural hurdle or a self-destructive tendency. It may be an active, external force. A chilling solution to the Fermi paradox is the berserker hypothesis. This idea, born from science fiction, proposes that a paranoid ancient civilization long ago may have sent out fleets of self-replicating, artificially intelligent probes. Their mission would be a simple and terrible one: to seek out any emerging biological or technological signatures in the galaxy, and to sterilize them completely before they can become a potential threat. In this scenario, the great silence is the sound of a galaxy that has been systematically and ruthlessly pruned. The filter is an ongoing, active, and intelligent predator, a Martian civilization. Upon reaching a certain technological threshold, perhaps the invention of radio or the first launch of a spacecraft, might have inadvertently tripped this ancient alarm. A silent, patient, and incredibly powerful berserker probe, lurking in the outer solar system, would have detected their signal and moved in to do its work. The nuclear catastrophe that Dr. Brandenburg proposes for Mars would then be the calling card of this probe, a quick, efficient, and total sterilization of the planet, leaving behind the telltale radiological signatures of its work. This would be the most terrifying filter of all, a filter that actively hunts down and destroys any new intelligence that dares to make itself known. It would imply that our own bubble of radio noise is a death sentence, slowly expanding outwards, and that one day the hunter may come for us as well. The Great Filter, in all its terrifying possibilities, is the ultimate shadow that hangs over our cosmic aspirations. It is the great unanswered question of our own long-term survival. The story of Mars, whether it is a story of a natural planetary death, a tragic act of self-destruction, or the victim of a cosmic predator, serves as the most powerful and proximate warning imaginable, a potential tombstone in our own backyard. But this warning becomes infinitely more personal, more immediate, and more profound if the beings who may have faced that filter were not just a cautionary tale, but were in fact our own kin. The story of a lost Martian world is not just a scientific theory or a distant cautionary tale. It becomes something far more personal, far more immediate, and far more profound when we consider the final, startling implication of the Panspermia hypothesis. The idea that the life that was seeded on Earth was not just any life, it was Martian life. And if that is true, then we are not just the neighbors of a dead world, we are its children, we are the Martians. This is the ultimate reframing of our own identity. It suggests that there may have been only one genesis of life in our solar system, a single beautiful and miraculous event that took place not in the chaotic oceans of the young hellish Earth, but in a calm, warm and ancient pond on the surface of Noachian Mars. Every living thing on our world in this view is a branch of a single family tree, and the root of that tree is not in the soil of Earth, but in the red, iron-rich dust of our neighbouring planet. Our own genetic code, the DNA that resides in the heart of every one of our cells, would then be the oldest and most profound artifact in the solar system. It would be a piece of ancient Martian biotechnology, a 4 billion-year-old operating system that has been running, copying and adapting itself to a new and different world ever since it arrived. We are the result of a single successful seed planted in a new garden that has grown and diversified into the magnificent and complex biosphere we see around us today. This raises a tantalizing and deeply speculative question. If our DNA is a legacy, a piece of software from another world, does it carry any memory of its original home? The vast majority of our DNA, the so-called junk DNA, has no currently known biological function. It is a great unread library of genetic information that we carry with us, a legacy of our long and complex evolutionary journey. Could there be, buried deep within these non-coding sequences, the dormant genetic memories of our Martian past? Could there be genetic switches waiting to be activated for biological traits that were once perfectly suited for a world with lower gravity and a thinner atmosphere? Is it possible that the great, archetypal myths and dreams of humanity, the persistent, global stories of a lost paradise, a Garden of Eden, a golden age from which we were exiled, are not just religious or psychological metaphors? Could they be a kind of faint, inherited genetic echo, a deep cellular memory of our true homeworld, a beautiful blue and temperate Mars, a paradise that was truly and physically lost to us? This idea casts a new and intriguing light on our species' long-standing and deeply emotional obsession with the planet Mars. From the very beginning of our history, we have looked to that red dot in the sky with a special sense of awe and curiosity. It was the god of war to the Romans, a symbol of power and conflict. In the early days of the telescope, we imagined it was covered in great canals, the work of a dying, intelligent civilization. It has been the setting for our greatest works of science fiction, from the terrifying invasions of H.G. Wells to the beautiful, poetic colonization of Ray Bradbury. And now, in our own time, Mars is the focus of our most ambitious efforts of exploration. We have sent more probes, more orbiters, more landers, and more rovers to Mars than to any other world. We are relentlessly, almost obsessively, driven to map it, to understand it, to drill into it, and to search it for signs of life, and the ultimate goal of our entire space program. The great dream that has captured the imagination of a generation is to one day send humans to walk upon its surface. Why? Why this specific world? The Mars origin hypothesis suggests an answer that is as beautiful as it is profound. We are drawn to Mars because we are, on a deep and subconscious level, trying to go home. Our relationship with our own world, the Earth, is also reframed in this light. We are its children, but we are also, in a sense, an invasive species, a successful and dominant one, but an alien one nonetheless. This could explain the strange and often destructive relationship we have with our planet's biosphere. It could explain that faint, persistent, and often unspoken feeling of not quite belonging, of being an outsider, an orphan, on our own home world. We are the orphans of a sky-faring ark, raised by a loving and patient foster parent, the Earth, who one day discover a single faded photograph of our long-dead biological mother, the planet Mars. We have our mother's genes, but we have no conscious memory of her. We only have a name, a picture, and a deep, unexplainable sense of connection. Our entire scientific exploration of Mars, in this view, is a quest to find the old family home, a search for a birth certificate, an attempt to understand who we were before we were forced to make the great journey and become who we are now. And this understanding makes the warning of the Great Filter all the more personal and all the more terrifying. If we are the children of Mars, then we carry within us the genetic and perhaps even the psychological legacy of the civilization that may have come before us. The same flaws, the same tendencies, the same hubris that may have led them to their own Great Filter may be written into our own code. The story of their fall is not just a cautionary tale. It is a family history. It is a prophecy, a warning from our own ancestors, written across the face of a dead world. This is the final profound reframing of our place in the cosmos. We are not Earthlings looking out at a strange alien world. We are perhaps Martians looking across the vastness of space and time at our ancestral home, the place where our story, the story of all life on Earth, truly began. This understanding changes everything. It means our future journey to Mars is not just an act of exploration. It is not just a scientific mission. It is a pilgrimage, a return, a search for the ghosts of our ancestors, and for the wisdom they may have left behind, a wisdom that we may need to survive our own coming tests. Our entire relationship with the Red Planet is now transformed. If we are the children of Mars, if our most ancient biology is a legacy from that lost blue world, then our future journey there is not an act of conquest or simple exploration. It is a pilgrimage. It is a sacred and necessary journey to our own ancestral home, a quest to find the ghosts of our past and to uncover the lessons that may be the only key to saving our own future. The story is no longer about them. It is about us. The first human footsteps on the surface of Mars will be the most significant moment in our history, since we first walked out of Africa. But in this new context, it is more than just a technological achievement. It will be a homecoming. The astronauts who take that first dusty step will not be explorers in an alien land. They will be archaeologists of the grandest scale, genealogists for an entire world, searching for the deepest and most ancient roots of our own family tree. Their primary mission will be the search for truth, the ultimate goal of our entire Martian exploration. In this view, is to drill deep, to push past the irradiated sterile surface and into the ancient Noachian rock layers beneath, the layers that have been protected from the harshness of space for billions of years. to drill into the great buried polar glaciers and retrieve a core of 4 billion-year-old ice. It is in these pristine ancient samples that the final proof may lie. Imagine the moment a sample of ancient Martian rock is brought back to an Earth laboratory. It is analyzed, and within it, scientists find the undeniable fossilized remains of a Martian microbe. But the discovery would not stop there. They would extract its genetic material, its ancient alien DNA, and they would compare it to our own. If the code is the same, if the foundational operating system of that Martian life matches the DNA of every living thing on Earth, then the case would be closed. We would know, with a certainty that would shake the very foundations of our identity, that our home is not our home, that we are the children of a lost and distant Eden. This pilgrimage is also a search for wisdom. The ghost of a dead Mars, whether it was ever inhabited by an intelligence or not, has a lesson to teach us, a profound and urgent one. By studying its dead climate, its lost atmosphere, and the reasons for its fall, we can learn, in excruciating detail, how a paradise can be lost. This knowledge is not just an academic curiosity, it is a survival guide for our own planet. The story of Mars is the ultimate environmental parable. It teaches us that a living world is a precious, complex, and fragile thing, that a planet's habitability is not a permanent guarantee, but a delicate balance that can be broken. Our journey to that dead world will instill in us a new and profound appreciation for the life of our own. By walking the silent, frozen shores of the lost Martian ocean, we will learn to better care for the living, breathing oceans of the Earth. The pilgrimage to Mars is a journey that will, in the end, teach us how to be better Earthlings. And in the very distant future, our connection to Mars may become a story of restoration, the dream of terraforming Mars, of re-engineering its atmosphere and releasing its frozen water to make it a habitable world once more, takes on a new and deeper meaning. It would not just be an act of colossal engineering, it would be an act of resurrection, a multi-generational sacred task to bring our ancestral home back to life, to restore the garden that was lost. Imagine the sky of that future Mars. As the atmosphere thickens over centuries, the sky would slowly turn from its pale pinkish tan to a deep Earth-like blue. The first rains in 3 billion years would fall upon the dormant, red dust. The great buried glaciers would melt, and the water would begin to flow once more in the ancient riverbeds, down into the great northern basin. The lost ocean of Mars would be reborn. The blue world, which was once just a memory, would live again. A future humanity, a two-planet species, could then look up at its sibling world, no longer as a red ghost, but as a living blue testament to life's resilience and intelligence's power to restore what was lost. And so we are left with this final, profound, and deeply hopeful vision. The Mars origin hypothesis may or may not be true. We do not yet have the proof, but its ultimate power is not in whether it is a fact, but in the story it tells us about ourselves. It is a story that takes our sense of cosmic loneliness and transforms it into a story of a lost heritage. It takes our future exploration and transforms it from a mission of science into a quest for self-discovery. The red star in our night sky becomes something more. It is a memory. It is a warning. It is a destination. And it is, perhaps, a home. The story of Mars is not a closed book from the deep past. It is an open invitation to the future, a silent and persistent call for the children of a lost world to finally, after billions of years of exile, begin the long journey of return.